So we're taking a look at the International Space Station in its course over North America. And what we see here is a red line and two blue lines. The red line indicates the trajectory, the path that the satellite's going to take, or the space station is going to take over the Earth. And the boundaries between the two blue lines represent what the current camera view is going to display. And we'll take a look at the website that we're using to display the camera view in just a moment. Now what we're going to do is to take a look at what happens if we were to say park our car at the beach and turn on our Baofeng radio and listen to the packet sounds, the audio that we get through X.25 packets, and see if we can pick those up with standard equipment. For example, the handheld Baofeng using a standard SBB7 antenna connected to a mag mount on a car. Let's see what happens.
Yeah, that's it.
So in the next episode, we'll take a look at how we can connect the X.25 audio to our Android smartphone so we can see the actual text messages that are being sent back and forth between the Earth and the International Space Station. So before we do that, let's take a look at this map and understand exactly what's happening. Over on the right, notice that we have a picture of the globe with the red line, and there's a white dot and a big circle around it. The big circle around it represents the parts on the Earth that would actually have visible a view of the space station. It would also indicate what areas of the Earth would have a signal that we could listen to or send to the International Space Station. Now notice that the orbit, the red line, the orbit of the International Space Station is a straight line. So it's essentially going counterclockwise depending on what angle you're looking at it. And the reason why the map on the left shows this like sine wave, this curve going up and down is that because the Earth is spinning, that represents the reason why there's this curvature going up and down. So if you can imagine, on the right side we see that the actual orbit is a straight line, it's a straight circle around the Earth, but the map is displaying this sine wave because the Earth is spinning under it. So one thing to keep in mind is that the SBB7 antenna is designed to mount on a magnet on the top of the roof so that, like a lighthouse, it would search around the car horizontally looking for signals from other ham radio operators. However, this is different. We're looking for the International Space Station and we expect it to be up above us. So what we can do is to attach the magnet to the door of the car and then point the car at the horizon where the course where the satellite or the International Space Station is going to come up, and this way we essentially get a 180-degree view of the satellite as it passes up and then over and then back behind the car. And the SBB7 has a high dB gain basically only in the direction that it's pointing, and this way we can actually pick up a strong signal from up above.